We've looked at the speeds of land and air vehicles and of spacecraft that enter the Earth's atmosphere at speeds of up to orbital speed. Let's now keep going up in speed. The next step is to consider superorbital speeds. Remember that for low Earth orbit, the speed required is around 29,000 kilometres per hour. If an object enters the Earth's atmosphere at a speed higher than this, we refer to it as being superorbital. The highest speed that a manned spacecraft has re-entered the Earth's atmosphere was in the Apollo program that sent astronauts to the Moon. This shows a sketch of an Apollo capsule during re-entry. The Apollo capsules entered the Earth's atmosphere at an amazing speed of around 41,000 kilometres per hour. The capsules were protected by an ablative heat shield that burned away as the capsule slowed down in the atmosphere. The maximum Mach number during Apollo re-entry was around 35. It's worthwhile looking at the speeds that spacecraft have entered the atmospheres of celestial objects other than the Earth. They also usually travel through the atmosphere at hypersonic speeds. Some are very high hypersonic speeds. Let's look at Mars. Many probes have been sent from the Earth to Mars over the past 30 years. The Martian atmosphere is much thinner than the atmosphere on Earth, and it doesn't extend to as high an altitude as does the Earth's atmosphere. The Martian atmosphere is made up primarily of carbon dioxide. For the same temperature, carbon dioxide will have a lower speed of sound than we would have in air. So that means that if we had a vehicle travelling at the same speed in an atmosphere of carbon dioxide and an atmosphere of air, the Mach number of the vehicle would be higher in the carbon dioxide atmosphere than in the air atmosphere. For Mars, the atmospheric temperature varies from around minus 30 degrees Celsius at the surface to minus 90 degrees Celsius at 30 kilometres. The corresponding speeds of sound are 880 kilometres per hour and 770 kilometres per hour. Compare that with around 1100 to 1200 kilometres per hour for the speed of sound in the Earth's atmosphere. So let's look at the entry of the capsule that carried NASA's Mars Curiosity rover in August 2012. This is an artist's sketch of the capsule approaching the Martian atmosphere. The capsule entered the atmosphere at a speed of 5.8 kilometres per second, which is around 21,000 kilometres per hour. That means it was travelling at about 25 times the speed of sound as it encountered the atmosphere, very much a hypersonic speed. We'll look at one final spacecraft entry in this unit. The highest speed that a spacecraft has entered the atmosphere of any of the celestial objects in the solar system was experienced by the Galileo probe when it entered the atmosphere of Jupiter. Here is a photograph of the probe before it was sent on its mission to Jupiter. This probe entered Jupiter's atmosphere in 1995 at a speed of over 47 kilometres per second. That's around 170,000 kilometres per hour. Now, the atmosphere of Jupiter is made up of hydrogen and helium, which have higher sound speeds. Therefore, despite the high speed, the entry Mach number was only around 50 for this entry. So hypersonic flow can be encountered not just within the Earth's atmosphere, but also on entry into the atmosphere of other planets and moons. We'll finish up by noting that most spacecraft that enter the Earth's atmosphere will experience hypersonic flow unless they're on a ballistic trajectory with a maximum altitude of less than around 200 kilometres. Spacecraft that enter the atmosphere of other planets, and some moons with atmospheres, also experience hypersonic flow. In the next unit, we'll introduce shock waves, what they are, and where we might expect to encounter them.